So I've got a Game Gear here. This one's a little bit different. You'll notice it's a VA4. I've only ever seen two of these ever. One I've got for developing the new clean screen, which is here, which another community member happily sent me. So the screen doesn't technically function visually, but the console seems to work. So other than having this board to look at, I've never even really seen VA4s and 5s. They don't tend to come over to the UK. But we've got one here for repair, so let's just see what we can do with it. So guy on Discord, Jason, basically had some issues with it. I think I was trying to help him on Discord and said it's probably easier just send me the actual console to look at. But basically, it looks like it was eBay junk. He installed some mods. One of the chips on the original screen was getting hot, I believe it says. Yeah, smoking hot. So there was a short on the screen. Recap the whole board. There's been a bit of work on it as well. He's tried to install the Benven IPS screen on this board, which technically should work. Benven's released a VA4 and 5 screen now. I haven't released the clean screen yet, just haven't got round to it. But the Benven one does work. We've seen it working. That seemed to have failed on the install. So whether it was a faulty board, faulty install, or faulty console, we'll see in a moment. Bit of history about what's going on, which is useful for places to look for potential issues. It says it doesn't get to red light boot. Some readings here, the 5-volt rails get to 0.7, which sounds like a short, so we'll be looking for a potential short here as well. But it's basically saying it doesn't get to red light boot. Missing caps, bad short. So generally this board has got quite a lot of potential issues. So from this, let's just take it that potential short and the VA4 doesn't work. So what are we going to do to start with? Well, to start with, I've noticed a wire hanging out here. Are these cables? Oh, wow. These are... Okay, that's a start. So the audio looks like these have snapped. That one's come out. Those have snapped. Anyway, we'll fix or replace that in a moment. Power. Let's check that as well. Power seems solid. Just that audio is completely ragged. Anyway, so we've got an audio cable there I can swap. But for now, we could check audio on the scope when we need to. The problem with the VA4 and the VA5, at the minute, there's no schematic. So we're kind of flying blind in a way. But if we look at it, it's pretty obvious. Power, audio, big transformer for the backlight. Clearly an op-amp, so this is like your audio section here. Looks like a 1 chip, wouldn't be 2 chip now with it being a later model. So it's like a 1 chip, so that means on the back normally is video RAM, on the front is work RAM. They look the same layout. So we kind of can make a lot of judgments from knowing the other consoles as to what the data is. These are like the caps and resistors for the screen. So that's what we really need to know. Now, the VA4 I've worked on, I know is a little bit improved. So I do know when you're powering these up, we can power them up slightly easier, mainly because the VREF pin has a better capacitor on that holds charge to keep the console in and out of reset. So let's just take my working console a moment, and let me just show you something on this console. You've got the same pins here. You've got the 34 volt, you've got the battery, you've got the VREF, you've got 2 grounds, 3 grounds I believe, and then 2 5-volt rails. The difference on the VA4 is the N2 5 volts here, they've separated into 2 channels. So the first one, if we tap on, we can see we're getting 190 milliamp. The second one, you can see quite clearly, is the screen's backlight. So it's a bit hard to see with the cameras. If I just chuck Sonic in, even though the screen isn't working, when we get a successful boot, you can see all I've done is put the 5 volts between both pads and the console boots. And we have the screen on one. And obviously this screen is damaged, so it's not going to work correctly. But I can boot the console here, and you can see red light boot with just that 5-volt rail. And if I tap on the LCD, it turns on this backlight, which you can see kind of here lighting the backlight up. But it's not needed for boot. So it's a good idea that they've split the two. And you can see the important thing is this current draw. So if we just boot up the console, if we want to reset this console, bear in mind this is VREF here. And you can see just touching VREF is enough to turn the console off. Because there's just a small capacitor holding a charge. And when we touch it, it's messing with that signal. The pin next to it, the VBAT, we've got connected to nothing at the minute, but there's enough voltage on that rail to just short between them and charge the capacitor to keep it high enough to keep the console in reset. So let me just show you a trick. If we hold the console with power on 5 volts, this is the pin we care about, the second pin in without the gap. So 34 volts, then a gap, then the battery voltage, which isn't connected, bear in mind, at the minute, and then the reference pin. This is what pulls the console in and out of reset. This pin next to it, VBAT, even when not connected, it has a bit of residual voltage on. So we can just short these two out, and you can see the console go off. When we let go, sometimes it comes back on, depending on if the capacitor discharges. We can discharge it by simply touching normally, and you can see it's come back on. But we can also short it to ground next to it to make sure it's discharged. So by shorting these two pins here, we charge the capacitor up on this reference pin and turn the console off. And either touching it or shorting it to ground brings the console back on. And if you watch the current draw here at the top, when we turn the console off, see how it's dropped to 33 milliamps? That's a big indication when the ASIC is held in reset and not doing anything. You bring it out of reset, and it comes to 130 without any screen powered up. So we're mainly going to be looking for power draw similarities to dictate the state of this other board. So with that, let's take this board. We know we've got to repair this now, this audio cable, so we can't reliably use that. But we can still probe the capacitors for audio to see the audio on the oscilloscope. So let's just solder onto the first 5-volt rail. We'll tap on first, but let's just get some wires ready. There's a ground point. So we've got ground there, 5-volt there, which we'll use in a moment to power the console and do some tests. We'll just touch on for now though, nice and easy. So ground there, and let's inject 5 volts on this rail and just watch for a short. And you can see it's got 90 milliamps, 96. That's like a sort of midway between being reset and not. And you can see we actually have red light boot. So maybe this is booting. Let's just check the backlight circuit. You can see that's got 50 milliamps. So something's still running on the backlight circuit that doesn't really need to be. So you can probably remove some more components to save some current. This power draw on this rail is kind of in between the two. But we are getting to red light boot for us. So I guess next stage is, let's flip over and power this from the bench. And let's crack out the oscilloscope. So we have the ground and power from the bench connected. Now we want to probe around the cartridge pins, just like on all the other Game Gears and the Retro6.wiki guide. Nothing's changed on the way the game is loaded. Let's just see if this is trying to load a game. So this should be 5 volts, which it is. And then we should have some address pins doing things. So this looks like it's actually trying to load a game as well. Okay, so let's put Sonic in. The power's just jumped up to 113 with the game in. Let's go straight to there. That's actually the game loading pin. So 1, 2, 3, 4, 5. To me, this is loading the game. So check audio here. Because the audio cable's damaged, can't really see audio there, but let me just change this to more of a audio friendly view. And then we're trying to visualize. There's a silence, there's noise. I think that's plain audio. I'm pretty confident that's plain audio. There's flat, there's audio. So those ripples look to me like this console is fully running. So is it just a case of bad cables? Because these cables literally fell apart. So let's try and go on the other side for the audio, just so we can probe going straight to the board. So we have SP on, which is for the combined speaker. And we have the left and right audio channels here. Yep, and bear in mind this is a DC blocked capacitor, but there you can clearly see audio happening there, and that's playing audio. So that's probably collecting rings in Sonic. Same there. So I'm pretty confident this is actually running. Now, there's not to say there's no problem with this, because we haven't really checked the screen or anything else. But this is clearly a major issue. This is like just fall out when I've handled it. So maybe we weren't hearing the audio, and maybe the BenVen screen was faulty or maybe installed wrong. There could also be still a power board issue, because I'm currently powering it through the bench. So if the other 5-volt rail had a short on, or if this VREF pin isn't handled correctly, we could still have an issue. But let's get audio fixed first, so I can actually hear the game loading and confirm what the scope's telling me, which is that it's working. And luckily, we've just had made brand new audio and power ribbons. So we'll sell these very soon, another week or two on our store. But let's just go and swap this one for a brand new connector. So you can see the only way you need to tell is you have one here, then a missing pin, and then some. So this has just got to go in the same way, where the missing pin goes in. These have on them these little springs, so these will be filled with solder. So before we can take these out, we really need to desolder wick them. Now you can desolder wick them, or you can grab them all in one go and pull it out, whichever you prefer. So let's just have a quick go if just pulling on the pins while warming every pad up is easy enough. And yeah, there we go. So it's a bit quicker than dewicking. You just warm up the pads all at the same time, and then you can pull this out. Let's just clean up these holes, because they will need to be completely clear for us to fit the new cable in. Take some flux, apply the flux, use some good braid. We use Gutwick, which is the best desolder wick we've found. So it won't really matter if you're working on simple holes like this, but when you get to more complicated, smaller holes or boards that absorb more heat, then this desolder wick is really going to make a difference. I just obviously use it for everything, because once you have it, you kind of don't want to go back to the other wicks. It's a lot tighter wick, and it comes with much better flux built in. If you struggle to get the solder out the holes, remember, plenty of flux on the board, and make sure your iron is set hot enough. And if you still struggle, swap your iron tip for a larger tip, because this is quite a small tip. You'd normally use a tip like this for desolder wicking versus this, because the heat transfer is much more with a larger tip. So a quick cleanup on here. We'll get our new cable connector, and if we remember, the missing hole, as you can clearly see here, is at the bottom, so this wants to go that way. So line up with the holes and push down, and this now fits in. You can see it's got a good fit there. So all we've got to do now is blob some fresh solder on these pads, and let's hope we have audio. I'm pretty confident with how the scope was showing the signals that we have audio. But now we've got a new connector on. Let's see. So back to powering the board. Let's put a game in. Put a clean amp on. And let's just reset the power. So you can see we've got red light boot here. The power draw is only 60 at the minute. And we don't have audio now. Maybe it's just the classic clean the cartridge pins. Let's reset the console while the power's applied. So we'll just short to there. And now the power's just jumped up to 116 milliamps. So I'm guessing, there we go, that's loading the game. Turn that down a bit. And you can see now resetting the console, you can do by this. And to start the console again, you can discharge. So let me just pass the power through the ammeter. And you can see we've got 74 milliamps and no game load. So if I just connect this with my hand, you see 74 milliamps, which is, we have red light boot, yet we also have a strange slight, I mean, that could just be a variance. We were getting like, what, 40, 50 milliamps on my clean, perfectly fine one when it was technically stuck in reset before we actually pulled out of reset. So maybe the red light boot, because it clearly works because these pins are toggling there, but maybe after it comes out of reset, there's still a time at which it's unstable, which is hence why these pins are here. And as soon as we reset, you see the current has gone up to 114, and I'll guarantee this will play audio now. There we go. So you can see though, if we disconnect power and connect, it doesn't come out of this reset. And that's likely just because the way I've got this rigged up, we're jumping straight into effectively what should be a successful boot without telling it that this needs to wait a while before coming out of reset. So it seems like we can get very consistent boot by applying power and then coming out of reset. That seems to work every time. And you can tell by this current draw what's going on. So with that, and if we take a clean juice, now you can get clean juice fit on these green connectors, but this is designed for the new white connector that clicks in. But if you want it to fit in here, all you have to do is sort of snip off this corner bit of white here. Just snip off the other corner white plastic. So it looks like this. And you can just bend this back, this white plastic here. You don't need to cut that off. And then what we do is when we insert this, we just have to remember that the way you think it might go in is the opposite. Look for the missing pin. So you can see here we're missing the pin here. The missing pin goes to the top. So this way around, effectively with the green that way. So to get that in, you just line up those pins and place it in. And you don't need to push hard because these are technically really tight pins for this connector. So you see I've only barely gone down, but that's made an absolutely rock solid connection now. I could possibly shift all these components over and add a double connector, but we rarely ever see these at all. I've done well over 1,000 Game Gears now, and at least in the UK, I've probably come across this green connector 4 times. But I can certainly add a dedicated connector to this if needs be. Or you can now just simply buy new connectors from us and put on the standard white one. But that's that. So we now have audio connected, clean juice connected, which should power this board fine. And let's look for red light boot while we do this. And let's see where the proper power supply does this work. So you can see we actually don't come out of reset at all with a clean juice. So if we do this and tap over, no. So interestingly, when using a clean juice, we don't come out of reset. So let's just take some measurements. Let's just get the multimeter ready. So with the multimeter connected, let's just take a look at some voltages when we turn on. So turn on, and we get 5 volt. Actually, now it sounds like it's booted. It has. Oh, you know what? I bet we've got the same issue again. I bet this power cable's not good. Yep, see that? So off, on, no boot. Yeah, so this cable's bad again. So this could have been a simple case of 2 faulty cables. Let's just do the same with this connector. Let's just whip off these. Now we know it boots with a clean juice. Insert the pins into all the holes and then just push down and it snaps through the holes. So now we have 2 brand new connectors on. And get the clean juice. Just remember now to connect the missing wire side to the top of the clean juice, so this way around. And there we have in now. So what do we reckon? Do you think this is going to boot first time and the issue is simply 2 bad connectors? Or do you think we're still going to have an issue? Let's turn it on and find out. And you can see first time boot. And then audio you can hear is already running. Fine. Turn off, turn on, perfect boot. Off, on, and I know because I can hear the game loading. When you turn it off and on, can you hear the audio? So I don't even have to wait for the game to load. You know Sonic's running by that. I think that Jason has actually solved the problems on this board successfully and just had bad power cable and bad audio cable. So he wasn't hearing audio because the audio cable was bad. And if he did get red light boot on the occasion, which I think he did on Discord when we were talking it through, he wouldn't have heard the audio again. So it was a combination of just two bad ribbons, I'm guessing. But luckily, like I say, we now have these. They'll be in stock in a few more days. That should have solved the problem on this. Just remember to diagnose this. The main thing we used was basically the amp drawage. It's a really good telltale sign when you use a bench power supply. How much power a system draws is very indicative of its current working state. So you can see the variance in this one. It sat at kind of 90 milliamps when there was no game, but it was in red light boot, and jumped to about 113 when the game booted. And the board I have, which is the only other board I've seen, is similar. It sits at around 40 or 50 milliamps with no game. I didn't really check with a game in that failed to load, but it jumped to about 130. So it seems like it's in the 100 milliamp range when it's working on just this 5-volt rail, not including the backlight. Hopefully you picked up some tips and tricks from this video and learned a few new things on diagnosing them. And luckily it wasn't too hard because there are currently no schematics for the VA4, so we would have been mostly flying blind, bar an oscilloscope. Jason can now chuck in a Benven screen with confidence, knowing that he can hear the audio, and if he has issues with that screen, he can contact Ben to get it resolved. But the likelihood is it had bad power as well as bad audio, so when the screens want more power for the backlight, the cable was probably failing and we just didn't have a clean power supply. If you guys want to see anything fixed you're stuck on and you're on our Discord, there's no charge for YouTube fixes. You simply send it in with a note and your Discord name and talk to me on Discord first. And if I think it's useful for our community, I'll do a video doing the live repair so you can see how I diagnose things. That's it for this one, and I'll catch you in the next.